Saturn displays an orbital system of remarkable diversity, ranging from impressive moons to a vast collection of rings that extend for hundreds of thousands of kilometers around the gas giant. To date, the only spacecraft that has dedicated itself to investigating this environment in detail has been Cassini, which revealed the complexity surrounding the ringed planet of the solar system. During its long mission orbiting Saturn, the probe encountered disc-shaped objects, possibly among the most curious ever identified in space. Today, in the space world, we will explore these enigmatic disc-shaped bodies found in the planet's orbit. Known as the second largest planet in the solar system, Saturn is also one of the most fascinating celestial bodies studied by humanity. Its majestic ring system, combined with a golden atmosphere filled with colossal storms, makes it one of the most photogenic objects observed since the invention of the telescope. Whether through ground-based instruments or space missions, gazing upon Saturn is like witnessing a universe of gigantic proportions and phenomena that challenge our understanding. But this incredible beauty may not last for long. Studies indicate that Saturn's iconic rings are gradually being pulled toward the planet due to its gravity, in a phenomenon known as ring rain. Scientists estimate that they could completely disappear in about 100 million years. Another curiosity is that one of Saturn's moons may harbor life. Enceladus, one of its satellites, has a subsurface ocean beneath its icy crust. The Cassini probe detected jets of water vapor containing organic molecules, suggesting that this moon may have conditions favorable for the existence of microbial life. Over the past decades, the exploration of Saturn has been marked by memorable milestones, with the Voyager and Cassini missions standing out prominently. In 1981, Voyager 2 flew by the planet and sent back astonishing images, revealing unprecedented details of its atmosphere and rings. However, it was Cassini, which orbited Saturn between 2004 and 2017, that revolutionized our understanding of this giant by precisely recording the characteristics of its atmosphere, moons, and intricate ring system. The images captured by the probe allowed us to observe, with clarity unattainable by ground-based telescopes, everything from the movements of the rings to minute details on the surfaces of the moons. At the end of its journey, the spacecraft was deliberately directed into a controlled descent into the planet, avoiding the risk of contaminating moons with potential habitability. Saturn also stands out for harboring an impressive collection of natural satellites, cementing its position as the planet with the greatest number of confirmed moons in the solar system. Currently, there are 146, surpassing Jupiter's 95. These bodies range from small rocky asteroids to true natural laboratories for astrobiology, such as Enceladus and Titan. While Enceladus, with its water and ice geysers, may hide an ocean beneath its frozen crust, Titan impresses with its dense atmosphere and lakes of liquid hydrocarbons, making it one of the most intriguing environments in the solar system. Among Saturn's most peculiar moons, some draw attention due to their unusual shapes and characteristics. Pan orbit between the rings and feature a shape reminiscent of flattened disks. This unique configuration results from the continuous accumulation of material along their orbits, as they interact with the particles that compose the rings, making them some of the most interesting objects circulating in the planet's orbit. For illustration, Pan has an average diameter of approximately 35 kilometers and travels through a gap in the rings, where its gravitational influence helps shape and maintain the structural division of the region. Located about 134,000 kilometers from Saturn, it plays a fundamental role in the dynamics of the rings. Similarly, Atlas, with a diameter of around 30 kilometers, shares the flattened shape and exhibits a pronounced equator, which gives it an appearance comparable to a flying saucer. Orbiting at the outer edge of the rings, Atlas interacts directly with the particles, influencing the structure of the rings themselves. The characteristic shape of Pan and Atlas does not occur by chance. Although the gravitational force of these small bodies is not sufficient to mold them into perfect spheres, it is enough to maintain their integrity. It is believed that the flattened shape is a consequence of a continuous process of accretion, in which ring particles gradually accumulate along the equator of these moons during their orbit around Saturn. Moreover, The rapid rotation of these satellites generates a centrifugal force that pushes material toward the equator, further accentuating this feature. Mutual interactions, both between the moons and the rings as well as among the particles themselves, prevent the uniform redistribution of material, resulting in the peculiar shape we observe. Another relevant aspect is the role of Pan and Atlas as shepherds of the rings. By exerting gravitational influence on nearby particles, these moons create ripples and gaps in the structure of the rings, while the particles themselves can affect the shape and even the orbital stability of the satellites. This delicate dynamic balance suggests that Pan and Atlas continue to evolve, gradually modifying their characteristics over thousands or even millions of years. Regarding the future, the prospects for these small moons remain shrouded in uncertainty and open up space for several intriguing hypotheses. Currently, one theory suggests that Pan and Atlas might continue to accumulate particles from Saturn's rings. This process of accretion, although gradual, could lead these satellites to reach a critical structural point where the excessive accumulation of material exceeds the internal strength of the bodies. When this limit is reached, the gravitational forces and tidal interactions exerted by Saturn's immense gravitational field may destabilize their structure, causing fragmentation. The pieces resulting from this breakup could then be reintegrated into the ring system, altering its composition and contributing to the complex dynamics that characterize the region. In contrast, a second possibility points to a scenario in which Saturn's rings gradually dissipate over millennia. If this process occurs, Pan and Atlas will lose the constant source of material that feeds and maintains their mass. Without this continuous replenishment, these small moons may undergo erosive processes or even be gradually pulled closer to the planet due to its prevailing gravitational force. This intense attraction could lead them to disintegrate, ending their cycles of existence and transforming them into mere fragments that would merge with the ring itself or disperse into space. Regardless of the fate that awaits them, these disc-shaped bodies exemplify the impressive complexity of the solar system's natural satellites. Their unusual appearance, a result of continuous processes of accretion, rapid rotation, and gravitational interactions with the rings, provides valuable clues about the mechanisms that govern the formation and evolution of small objects around large planets. The peculiar morphology of Pan and Atlas reveals how even the smallest celestial bodies can play important roles in the dynamics and architecture of planetary systems. It is worth noting that many of these secrets could only be unveiled thanks to space missions such as Cassini, which, by orbiting Saturn for more than a decade, provided high-resolution data and images. Without the contributions of these missions, such fascinating details about the interaction between moons and rings would probably have remained hidden, limiting our understanding of the complex processes that govern our solar system. If you enjoyed this content and wish to continue exploring the mysteries of the universe with us, don't forget to leave a like. Your interaction is essential for us to keep producing informative and inspiring videos. And if you haven't joined our community yet, click the subscribe button below so you don't miss any updates. Thank you for watching. Until the next video.